So guys, this is not college algebra. This is how to use your textbook. So let me just start talking. If you have a physical copy, this is irrelevant, right? But some of you have bought the, college algebra, MyLab access. Notice this is recommended. So like I recommend you either get this or that, or ostensibly you could get an older edition of Lyle and use that if you just want to have a textbook sitting around to have college algebra textbook. Because again, I have the copy available that you can copy problems out of and to look at the recommended homework and such, right? But if you do get the MyLab access 24 months, that does get you access to the ebook, I think. Let's see how. It's kind of complicated. So like if you bought this, then you have a code, right? Not a access. You don't have a course code. There is no course code for one thing. So you probably, if you got that, this is what happens every year. Students go to the Pearson website and ask you for a course code. There is no course code. I wish the bookstore would communicate this to you guys directly. It is a source of continual annoyance to me, to be honest. And so we have to go to Canvas. And then you click on the MyLab mastering thing here. And so I did that. Okay, are we all on the same page? You guys with me? Then I click on Get Started, like that. And then let's see here. Well, see, that's no help because I am. Well, let me just try this. Fine. I don't really want to do that. All right, well, I guess I'll have to mess with this after class, guys. So what happens for you? See, this is the trouble, is I can't really show you because I'm the instructor, so it's different for me. Have any of you tried clicking on that? What happens?
We don't have that option.
You don't have, there's no MyLab mastering? Oh.
Welcome, and there's an option for help and stuff.
All right, let me see here. What do we want to take? We'll make today the start. How about that? End date. I'll make it October 28th there. Why not? Create course. Course name, Math 121, Spring 2023. Cook. Oh, 6 hours. Well, Well,
It gives us the option now.
Interesting. All right, so let's we go back here, refresh. An error has occurred. So for you, maybe. What happens when you click on it? Okay, so now you're getting to this. You agree with the terms. You click on that, and then so if you email me about this, I sent you a PowerPoint and then that PowerPoint might start making sense now. So it's like 3 screens. You had to go to this Yuzu site. It's As you can see, it aggravates me. All right, so anyway, so I think that was my fault that I hadn't clicked this and done that. Now, I'm hoping that by doing this, I haven't inadvertently messed up my Canvas. I'll have to look at it. Because there is no required homework through MyLabs, right? This is just a means for you guys to see the ebook in this course, all right? So is that clear enough? All right, so I will give it a few hours for me, and then anyway. All right, so put that. Oh, wait a minute. Did I? Yeah, I already did the top hat. So. Again, with Top Hat, that is not what matters so much. What matters more is this attendance sheet here. This is how I'm going to actually look for the number of, eventually they'll ask me, what's today's date? It's the 19th? Thank you. So 17th was the first day for us in here, right? So at some point or another, I'll have to write a progress report, and they'll be like, how many absences did such and so forth have? I will not look at Top Hat to rat you out on your lack of attendance. I mean, I don't really want to at all, but I will look at this sheet and I will count, where were you missing, and that's how I'll count number of attendances, all right? So if for some reason Top Hat isn't working for you someday, relax, it doesn't matter, okay? But do try to check this sheet when you're here. And if you're not here, don't check it. So that should be easy enough, right? So sorry if you bought the ebook and it's causing you trouble. The good news is that you can look at the problems in the book that I have outside my office while you're figuring that out. Yep. Yes, you can purchase that, or I think they have like a loose leaf in the bookstore from what I saw, and he told me there was a rental option for like $70 when I emailed him. I don't see that there, but allegedly there's like a rental option. All right. Do any of you want to look at the textbook right now? I have it with me. So if you'd like to just take like a quick screenshot of, a quick photo of like the problems that are recommended for this week, you could do it. You have phones, right? So, and I have, I got sticky notes here in the 3 sections where I've recommended problems. So if you guys just want to pass the book around and do it in class today, for today, that's fine. I won't always do this, but since today it's probably an issue. Anybody want to start? All right. Sorry, you ladies are out. You guys are fine? Okay. One of the last semester, I had a group of girls that sat right where you guys are, and they were kind of mean to me, so I started referring to them as the mean girls. But you guys seem nice. So I don't feel like I'm going to need to come up with, I'll have to come up with a more pleasant title for your grouping. All right, so, yeah, so I don't think it's entirely obvious how to set up the ebook, guys. Like, if you buy the MyLab Access, you have to go, first of all, it has to be done through Canvas. Once I've done my part, which apparently I've now done, you can hit the MyLab Mastering button. That takes you to a Getting Started screen, which then after you read a page of legal mumbo jumbo, you agree to something, it takes you to another thing.
Well, then it takes you to where you can put in access code,
Uh-huh.
which the bookstore did not get.
Check your email and your other.
Yeah, it's also on your receipt.
And this is why we should use books. Books, not ebooks. Because, like, I don't know, this is really not the first semester that this has been an issue. All right, although, admittedly, the first part was my fault. So, all right. Let me begin with a word of prayer. So, actual class starts now. Heavenly Father, we thank you for this day. Thank you for these students. Just ask that you guide our work today and just help us to understand math together, Lord. In your name I pray, Lord Jesus. Amen. Okay, so, I just realized a flaw in my logic. I was going to look up look up problems out of that book while I taught today. Well, but I wrote the problems out on a piece of paper. I did that. And you know what I did with that piece of paper? I left it in my office. All right, so it's okay. I'll just have to make up some problems. So example 1, let's try to solve something like 1/2 plus 1/3 x minus 2 equals to, oh, I don't know, 1/5, something like this. How do you solve an equation like this? I mean, we worked some problems like this last time, just not with this kind of annoying pattern, right? So you had an idea? Somebody had an idea. Let me fix this. I had it zoomed out for the... So you think you can track with me?
With the, oh yeah.
Yeah, okay. Okay, so yeah, if you sit there, then you become the cameraman. Such is life. But the good news is after you do this, I can write you a letter of reference as to your experience as a videographer. So, you know, it's a good thing. Okay, so what should I do? Yep. Distribute the 1/3. I'm going to that we could do that. Yeah. We could do that. Yeah.
Give the common denominator of all the 1/2, 1/3, and then the 1/5.
Convert to a common denominator. We could do that. Yeah. Still looking. I think you're on the closer. What could we multiply this equation by to make our life easier? 3?
Well, I said
Multiply by 3, that's the start, yeah. And? Multiply by 5, that's the start. And 2, I'm going to take all three of your answers, put them together. 3 times 5 times 2 is what? 30. Let's multiply this equation by 30. Because that's the least common multiple of the denominators. And now all of the things you guys were telling me to do, totally reasonable steps, but not lazy enough. All right, let's be lazier. So multiplying by 30 is very nice because then we have to distribute. So this is 30 over 2 plus 30 over 3 times x minus 2 equals to 30 over 5. What's 30 over 5? 6, right? Then let's distribute, well, let's simplify first, right? We got 15 plus 10 times x minus 2 equals to 6. Right? So you got choices. You can either distribute the 10, right? Or, do you guys want to do that? Distribute the 10? We can do that. So I'm going to subtract 15 to the other side. Yeah? So I get 10 times x minus 2 is equal to 6 minus 15, right? Now 6 minus 15 is what? -9. And this is giving me 10x minus 20 equals -9, right? Then if I add 20 to both sides, what happens? -9 plus 20, I heard 11. So what's this tell me x is equal to? Yeah, 11 over 10, right? So one of the key ideas of the calculation I'm doing is that when you have a number multiplying a sum of things, it has to multiply each one. Like, so up here, when I multiply 30 by the equation, the 30 multiplies not just the half, but also the third, right? There's this distributive law. So like A times B plus C, we have to do AB plus AC, right? this is how we multiply. Any questions about this? Yeah.
Do you mind just slowing down?
Well, if you ask a question, I'll stop. But Yep.
Why does nothing happen to the x minus 2?
Why does nothing happen to the x minus 2? Well, we multiplied it out here.
Yeah. I just meant like when you multiply everything by 30, how come x minus 2 stays constant?
Well, we multiply the 30 up here. So it's 30 times this plus 30 times that.
All right.
So, yeah.
What's that formula on the top right?
The formula at the top, this is the distributive law. So this is the, like basic law of algebra that we're following when we make this step going from here to here. So think of it this way. I think of this as being like the A. This right here I can think of as being B. Excuse me, other way around. B, my bad. B and C. And then I think of this as kind of like an A. So that's the pattern. It's A times B plus C, I've got A times B here and A times C here. That's the pattern, the distributive law that I'm using. I'm saying this because some of you are getting the problem wrong in the homework because you're just multiplying the 30 basically just by the first fraction but not by the second one, But when we multiply a sum, we have to multiply both terms. So, yes, if I'm ever going too fast in here, there's a simple way to stop me. It's just ask a question. Yep. Mm-hmm.
So if you don't have something in a parenthesis, like if it was, like instead of having 1/3 x minus 2, like if you had just x minus 2 over 3, when you're multiplying it by 30, would you do would it just be 30x minus 2 over 30? You know what I'm saying?
Not quite. You're saying, what if you just, example 2, let me make up a problem for you. So something like if you had 1/3 x minus 2 equals to 1/7 or something like that, would that be?
No parentheses.
Oh, no parentheses.
So like x over 3 plus.
So like this plus 1, minus 2 maybe, like this.
Well, it would be like minus 2x over 4.
You're fine. So minus 2x over 4
And then equals,
equals what?
you can choose 1/7 again.
1/7? Okay, sure.
And so then when you multiply 3 times 4 times 7, and you get that number,
Mm-hmm.
which is 12 times 7, is that 56?
Right, so yeah, 3 times 4, that's right. I would multiply this one by 3 times 4 times 7, which is 12 times 7, which is 84, right?
Okay, so you have 84 over 3x.
Uh-huh. So I would multiply by 84, which you could leave as 3 times 4 times 7 if you like, So I multiply the equation by 3 times 4 times 7. And then I have to distribute. See, so this gives me 3 times 4 times 7 times 1/3 x minus 3 times 4 times 7 times 2x over 4 equals to what? Now this over here simplifies, yeah? The 7's cancel, they reduce, and you're left with 3 times 4, which is 12, yeah. And what else? We have another reduction, right? Like 3's be canceling over here, and the 4 cancels there. So what do you got? You've got 28x minus 3 times 7 times 2, which is 42x equals to 12.
And then just combine.
Yeah, and then what's 28 minus 42 is what? What's that? Negative 14?
X.
Oh, okay. Yeah, yeah. I think that's right. And then we divide by minus 14, and we get x equals to 12 over minus 14. Which we can simplify, right? Because 12 is 6 times 2, and 14 is 2 times 7, so... So we get x is equal to minus 6 over 7 for this one. So I wanted to go back, like we did some of these last class, right? But I wanted to go through some more ugly ones to try to like talk a little bit about how we deal with fractions, yeah? There's another kind of problem we haven't faced yet for these, which I should go over. It's not really a different kind of problem, but let's just talk about it. So what if you had like 0.1x plus 0.3 equals to 0.6x minus 2? How do you solve a problem like this? Yeah?
Minus 0.1x
Uh-huh.
to both sides.
Okay.
And then
Okay, so let me get catch up to you here. So that gives us 0.3 equals to 0.5x minus 2, right? And then what?
plus 2 to both sides.
Add 2 to both sides, okay. So we get what, 2.3, 0.5x. So what's x equal to? Divide by the 0.5, so we get 2.3 divided by 0.5, which is the same as multiplying by 2. That gives us x is equal to 4.6. So I think that's a perfectly good way to do it. Do you guys have any other ideas? Like, what's another way we could do this problem? Yep.
Multiply it by 10.
Yeah, multiply by 10 at the start. So if we multiplied by 10 at the start, we get what? 10 times 0.1x plus 0.3 is equal to 10 times 0.6x minus 2. The key idea here is this distributive law. We must obey the distributive law, right? So we have to multiply the 10 on both terms. And when you do that, what's 10 times 0.1? 10 times 0.1 is just x, right? It is 1. 10 times 0.3, 3. 10 times 0.6 is 6. That gives us 6x. 10 times 2 is 20, so minus 20. Right? Now we subtract x from both sides, right? So if I subtract x from this side, I get 3 is equal to 5x plus minus 20, rather. And then what? Add 20 to both sides, right? And that gives us 23 equals to 5x, which then gives us x is equal to 23 over 5, right? Which, if you want to make that into a decimal, you get what? 4.6, okay. That's good. I'd be very embarrassed if we got a different answer the other way, you know? Yep.
Why do you choose to multiply first by 10? Like all the way up to some top.
Oh, if I'm dealing with decimals, you know, multiplying by 10 will make them all into numbers, like whole numbers, yeah? So if I had another problem where I had like 0.17 and 0.37 as part of like the coefficients, in that problem I would multiply by 100, you know, because the natural, if you don't, I mean, decimals are a pain, right? So 0.17, that's kind of annoying. But if I take that, right, and I multiply by 100, I get 17. And so we do better in algebra if we just deal with whole numbers, right? So that's the theme of this first, 3 examples, is if you have fractions, maybe you should multiply by the product of their denominators to turn them into whole numbers so you don't have to work with fractions. Now, can you do the problem just using fractions? Well, sure, right? But it's better not to. We good? Let's talk about lines again. So I want to talk about parallel and perpendicular lines. So number 1, if y is equal to m1x plus b, well, let's just say this. Y equals m1x plus b, and y equals m2x plus b. If, and let me say this is y1, we call this y2, then 1, if m1 equals to m2, then the lines are parallel. So if they have the matching slopes, 2 lines that have the same slope are parallel lines, all right? 2, if m2 is equal to minus 1 over m1, then the lines are perpendicular. Right? We talked about how to graph lines last time, right? So let's look at an example of this. So let's say, suppose y equals to 3x, not 3, let's say 2x minus 3 has parallel line with y-intercept 6. Find the equation of that line and graph both lines. So this mystery line, what's the slope of the mystery line? Y equals what? Yeah, y equals 2x. And what's the y-intercept? 6. So y equals 2x plus 6. There you go. That's the equation of the line. Okay? And then what? I wanted to graph it, so I'll do that over here. So the y-intercept of the given line is minus 3, right? So maybe like here, and it's got a slope of 2, so up to the limits of my artistry, there it is, y equals 2x minus 3. There's the given line, yeah? And then where's the parallel line? It's got a y-intercept of 6, right? Which is like twice as far above the x-axis as the other one is below, so it's got a kind of like up here-ish, right? And it should have kind of like, these are supposed to be parallel. I'm trying, guys. So the red line would have the equation y equals 2x plus 6 here, yeah? And there you go. Okay, let's see here. Example 5. Find perpendicular line through, let's say, 1, 8, for the line graphed below. So here we're going to be given a graph. Some of the recommended homework problems, you're given a graph, right? So like, suppose we have this graph like this, and we're given that there are 2 points on this graph. Let's say this point is -2, 0, and let's suppose this point over here we're given is, oh, I don't know, 8, 6. All right? So this is what we're told. We've got a graph, we've got a line, we've got 2 points on the line. We're asked to find the perpendicular line that passes through the point 1, 8. Let's make a picture of what we're trying to find before we actually calculate it. Tell you what, let me, no, it's fine, it's fine. I was worried I had put the point where I really couldn't graph it. I think we're okay though. So 1 and then 8, so it's as far up as this one's over, right? So if I did it right, it should be like here is that point, right? What does the perpendicular line look like? So we're trying to find the equation of this dotted line right here, right? It's perpendicular. So it's supposed to meet at a right angle like that, yeah? How do we find the equation of the blue dotted line? Yeah. Y2 minus Y1. Yeah, so let's, let me remind everybody our standard formulas for lines, right? So we had what? We had y equals mx plus b, right? That was slope-intercept. I think you got the right idea. I just want to remind people what you're talking about. We also have the point slope, which was y equals y1 plus m times x minus x1, right? So this was point slope, right? And what did we say about how do we calculate the slope? M was rise over run, right? Which you could say change in y over change in x, or more to the point, you could say y2 minus y1 over x2 minus x1. These are typical formulas for a line. Now, these don't cover everything, right? There's also another thing called intercept-intercept form, right? And then there's special lines, like vertical lines, which don't quite fit this pattern, right? What's the equation of a vertical line? Vertical line is something like x equals to x naught. What's the slope in this case? Your textbook has some questions is like, find the equation of a line with an undefined slope. That's a vertical line. Some people say the slope's infinity, you know, whatever. So m equals infinity or undefined. Right, so once I'm done with this example, I'll come back and derive the intercept-intercept form for you guys. Okay, I don't remember that one off the top of my head. There's also something called the standard form, which is kind of funny to call it the standard form because like nobody uses it. So anyway, I mean, for you guys, I think typically the standard form is just y equals mx plus b, right? Yeah. That's like what you're used to. I am a fan of point slope. Okay, so what's the equation of this line? So I guess we need to find the slope of the black line, right? So the solution, so this was the problem. Now I'm doing the solution, okay? First, we'll find the slope of given line. M is, let's see here, 6 minus 0 over 8 minus a minus 2. So it looks like the slope is going to be 6 over 10, which we could simplify to 3/5. Right, so the slope of the given line is 3/5, meaning that it goes up 3 every time it goes over 5. Right? You go over 5, you go up 3. Even with my not quite awesome graph of it there, it kind of looks like that, right? Eh. All right, what's the slope of the perpendicular line then? Minus 1 over m, right? What is minus 1 over 3/5? What's the reciprocal of a fraction? Well, you just flip the fraction, yeah? 5/3, and of course we don't forget the minus, right? Okay, so that's the slope of the perpendicular line, right? And then what? Now I know its slope, how do I find its equation? Yep.
So if we have, if we're trying to solve the perpendicular lines, are we always going to use the -1 over m?
Yeah.
Okay.
That's the deal. The slope of the perpendicular line is the negative reciprocal of the given slope. That's the rule. If we're trying to find a parallel line, we just use the same slope, like in example 4, right? And what else could happen? Well, all kinds of other things could happen, right? Like, generally speaking, lines are all different kinds of crazy ways, right? Like, more generally, you just say that they're skew. The lines are skew, right? They don't have to have the slope between one line and another doesn't have to be any nice way related, you know? This is a very special case when the one slope is the negative reciprocal of the other. What point is on the perpendicular line? We know what? 1/8 is on the perpendicular line that we're looking for, right? So the natural choice to use here is my beloved point slope formula. So we do, here we go, y equals to 8 minus 5/3 times x minus 1. And we could leave it like that, right? I mean, that's a perfectly legitimate answer. That's the equation of the line, the perpendicular line, right? If you want to, we can multiply this through and clean it up. What do we got? We got y equals 8 minus 5/3 x plus 5/3. How many thirds is 8? 24. 24 plus 5 is 9. So what we got here is y equals to 29 over 3 minus 5/3 x. There you go. This is the equation of the perpendicular line. Now, you might wonder, like, so, I mean, besides just punishing or you know, trying to harass college algebra students, like, why do you care about perpendicular lines anyway? I mean, like, who cares about perpendicular lines? Any of you guys have geometry in high school, like compasses and stuff? Do you remember perpendicular lines are interesting because they're one of those things you can construct using compass straight edge constructions, right? So that's kind of neat. But there's another purpose for perpendicular lines. They answer interesting questions. Like, here's a question that we can ask and answer with what we've done on the board. All right? Like, here's the question, follow-up question. What point on the given line is closest to 1/8? How do you, well, I mean, this is a larger question. If somebody says, here's a line, you know, let's say this one, y equals x, right? And then I ask you, how far is it to the point 0, 8? Enough 8s, let's say 7, there we go. How close is that point to the line y equals x? What's the answer? What do we mean by that question? Yeah.
Is it like when y equals a certain number and x equals a certain number?
Yeah. I mean, there should be a point, right, which is closest. My question is, how far is the point from the line? Like, what do we mean by that? Because there's more than one point on the line, right? So, like, if I calculate the distance from this point to the origin, which is on the line, right, that would be distance what? 7, right? And there's another point over here, right? That point 7, 7. How far is the point 7, 7 from the point 0, 7? That's also 7, right? So is the distance from the point to the line 7? Well, no, right? Because you could do better, right? Like this point here is closer than 7. This point here is closer than 7, right? What's the closest point? The closest point is the perpendicular line. The perpendicular line to y equals x, which goes through 0, 7, that should intersect the given line here, y equals x, at the point which is closest to 0, 7. Same thing here. To find the point closest to the given line, to the point 1/8, we just need to find where the blue dotted line intersects the given line. Right? What's the equation of the blue line here? The perpendicular? If this is the line y equals x, what's the negative reciprocal of the slope here? This has slope what? Slope 1? So what's the reciprocal of 1? 1 over 1. So the perpendicular line here is just y equals minus x. And I was nice in this made-up example here because the y-intercept is 7. So the formula for the perpendicular line here is just y equals minus x plus 7, right? So this over here is a much easier example than my example 5. And if we continue it, we can find that point. What is this point right here? The point on the line y equals x, which is closest to 0, 7. How do I find that point? This point, this is where both line equations hold true. All right, both line equations hold true. In other words, it's where minus x, x, come on. In other words, where x is equal to minus x plus 7. Now we can solve that. You can solve that all day long, right? That's easy. We add x to both sides, we get 2x equals to 7, yeah? 2x equals to 7. So x is equal to 7 halves. So the point which is closest to 0, 7 on the line y equals x is this point right here, which apparently is 7 halves. 7 halves. closest point on y equals x to the point m07. Now, the answer to my follow-up question to example 5 is not going to be as pretty, right? It's the same idea as my example 6 here. All right? Let me just take a breath here. Any questions? So let me review here. For example 5, we found the equation of the black line was actually what? Right here, right? This is the, excuse me, that's the equation of the perpendicular line. This is the blue line, right? The equation of the black line, what was it? Oh, we never found it, did we? Right? So we actually have to figure that out in order to answer this question. What's the equation of the given line? Well, the equation of the given line, we know its slope is what? 3/5? So given line y equals to, pick whichever point you like, yeah? I'm going to use this point right here. So 0 plus, what is it, 3/5, x minus a minus 2. There is the equation of the given line by point slope. And so specifically that works out to 3/5 x. Well, I'll keep the 3/5 outside. 3/5 times x plus 2. Okay, there's the equation of the given line. Right next to it is the equation of the perpendicular line. Right? If we want to find the point of intersection between the perpendicular line and the given line, we solve them, we set them equal. Right? So to find this point right here, I would set my two equations equal here. So to find this point right here, I would set 3/5 x plus 2 equal to 29 over 3 minus 5/3 x. And you'd have to solve that to find that point. It's not going to be anything pretty, like my other example. Should we solve it? All right. I need to erase something so I have room to work where you guys can see it. I'm going to have to, this is going to have to go. So to find the point of intersection, we're solving 3/5 times x plus 2 equals to 29 over 3 minus 5/3 x. All right, so going back to the start of today, I think we should multiply this by the common, like least common multiple denominators. Multiply by 15, yeah. So multiply by 15. That gives us 15 times 3/5 x plus 2, right? Equals to 15 times 29 over 3 minus 15 times 5 over 3 x. Which we can simplify, right? Like 15 over 5 is 3. 3 times 3 is 9, so I have 9 times x plus 2 on the left-hand side. 15 over 3 is 5. 5 times 29 is 145. And 15 over 3 is 5. 5 times 5 is 25, so I got minus 125. Wait, excuse me, minus 25, my bad. And then we distribute. We get 9x plus 18, 145 minus 25x I want to isolate x, right? So I'm going to add 25x to both sides, subtract 18 from both sides. So I get 9x plus 25 equals to 145 minus 18. Lost my x. See, 9 plus 25 is 34. So this gives me 34x equals to 125 plus 2, 127. So x is apparently equal to 127 over 34. So I've now found that this point right here, yeah, is at 127 over 34. And how do I figure out the y coordinate for that point? Yeah?
You plug that number in.
That's right. I had to plug that number in. Which one? Which formula? Trick question. It doesn't matter. It's on both lines, right? So like, you could go with one. You could go with either equation. You just got to plug it in. I don't really want to. Fine. 29 over 3. This is what I get for giving you guys that book to look at. I was going to work book problems today. Easy peasy, nice fraction book problems. But no, I have to make up my own problem, dummy. Me, not you. Let's see here, 127 over 34. And then you could simplify that fraction. That would be the point on the given line, which is closest to the point 1, 8, right? So this is an application of perpendicular lines. If you're given a line and you want to find a point on that line which is closest to a point off the line, you can track where the perpendicular line hits the line, and that'll give you the closest point. That's the idea. There's a problem in your homework like this is why I'm talking about it. I think the problem in your homework is easier than this, most likely. I sure hope so. I don't think this problem is really hard. It's just is unfortunately in combining a lot of ideas at once. All right, so enough about this. Let's get back to solving systems of equations, which is what I was supposed to be doing a half hour ago. All right, I'm going to resist. I mentioned something about deriving the intercept-intercept form of the line. I am not going to listen to myself. I'm not going to do that. That would be destructive to this lecture. So let's go on. Any questions before I start erasing like mad? Okay. Cameraman already got everything?
Yeah.
Okay, that's an important question. I will eventually, maybe eventually I'll learn your name and you'll become not just cameraman, but you know, at the moment you're just cameraman. So, I guess it's not a bad thing to be. There are worse things. Okay, so solving systems of equations. Let's talk about it. So I guess this is my example 7 for today, yeah? So let's suppose we've got 3x minus 4y equals to 2, and x plus 4y equals to 10. When you have an equation like this, the right way to solve a system of equations like this is to either add or subtract equations. Why do I say that? Well, the goal is really here to eliminate one of the letters, so you just have one letter, yeah? So, like here, if I just add these equations, right? The minus 4's and the 4 cancel, right? And I'm just left with 4x equals to 12, yeah? Which then gives me x equals to 12 over 4, also known as 3. What's y equal to? So we could do this, right? x plus 4y equals to really 3 plus 4y, right? And that's equal to 10 by equation 2. So what's y equal to? We've got 4y equals to 7, y is equal to 7 over 4. So the solution is 3, comma, 7/4. So the solution to a system of equations, 2 equations and 2 unknowns, is a pair of numbers, right? Now sometimes we write them separately. We'll write like x equals something and y equals something, yeah? But it's a pair of numbers. And like the reason for that, in part, is that we can always go back to this graphical way of thinking, right? Each equation represents a line. We're looking for the point of intersection of those 2 lines, yeah? So, golly, like this right here, oh, I don't even write it down. I could write down a system of 2 equations here, right? We solved y equals 29/3 minus 5/3 x, and y equals to 3/5 x plus 2. We solved both of those equations at once. That's what we just did over here. This was 2 equations and 2 unknowns. But that one was ugly. This one, eh. All right, so up next here. What if we have this? 3x plus 4y equals to 1, 5x minus 6y equals to 2. How would you solve a system of equations like this? Yep. Mm-hmm.
So, or what I would do is,
Sure.
is get, like, take one of the x's or the y's, and then you multiply it to, like, for the first one, 3x, you multiply it by 5, and then the next one by...
So you want to use the same idea we did in example 7 for it, right? Is that right? So if I am to read your mind a little bit, I think is what you said. Multiply by 5, we get 15x plus 20y equals to 5. Multiply this one.
But I mean by -3.
Oh, by -3. Ooh, interesting. So minus 15x plus 18y equals to minus 6. I mean, I'll allow it. Why not? You could do that, and if you did that, then we could add the equations, right? So her approach, which is a good approach, is just to manhandle the equations and make them match up. Multiply one by the right number, the other by the right number, so that they have a term which matches up, so that when you cancel them, they cancel. I mean, add them, they cancel. Perfectly legitimate way to do this. So, great. What's this give us? That gives us 38y equals to minus 1. Apparently y is equal to minus 1 over 38 then. What's x equal to?
It cancels.
What's that?
Well, I was going to say the x.
Oh, yeah, exactly. But what is x now? We figured out y is minus 1/38. Now what is x? Yeah.
So are we not able to add the inside of like add all together, like what is
I just did that here. So if we add these 2 equations,
No, the first,
well, you could add them. Sure, you could. You can add them. No, you can do that. You can always add equations. It's just not helpful. See, because when we add them, we get 8x minus 2y equals to 3, which is still an equation with both x and y. See, our goal is to eliminate either the x or the y, so we get one equation and one unknown, because we know how to solve one equation and one unknown all day long, right? It's not a problem. We did that already. We know that. Isolate the variable. So isolate 2 variables. Blah. So that was the strategy, to make it match up so we could cancel. Now that we've got that, you could go back to either one of them that you like to figure out the x, right? So what do you guys want to do, the first equation or the second equation? The first one? Okay, so 3 times the x we don't know plus 4 times the y we do, 1/38, right, is equal to 1. So that gives us 3x is equal to 1 plus 4 over 38. How many 38ths is 1? It's 38 38ths, right? So this 38 plus 4 is 42 38ths.
Question.
Mm-hmm.
Wouldn't that be a -4?
It would, but I added it to the other side. So I had to move this over to there.
Oh.
So when I do that, that minus becomes a plus.